We use it every single day, but have you ever really stopped to think about how the internet actually works? What's going on in that split second between you hitting enter and a website just appearing? Well, let's take a journey and break it all down.
It really does feel like magic, doesn't it? You type an address, hit the button, and poof, a website just appears. But it's not magic. Behind that one simple action is this incredibly fast and complex series of steps, and we're going to follow that journey from the very beginning to the very end.
So, to wrap our heads around this, let's use a simple analogy. Just think of the internet as the world's biggest and fastest postal service. Seriously, every time you click a link or type in an address, you're essentially sending out a letter and getting a package delivered right back to you, all in a matter of milliseconds.
So at its absolute core, the internet is really just a planet-spanning network of computers all talking to each other. But the key, the secret sauce, is that they've all agreed to speak a common language, a set of rules called a protocol that makes sure every computer can understand every other computer perfectly.
Okay, so here's our roadmap for this trip. We're going to follow the 4 main stages of this journey. It all starts with you typing that URL, then something called a DNS lookup, a response from a server, and finally, your browser putting it all together.
All right, first up, decoding the address. Every request, just like every letter, needs a destination, and on the internet, that's the URL. You know how a physical address pinpoints a specific house on a specific street? A URL, that stands for Uniform Resource Locator, does the exact same thing. It pinpoints every single resource on the web, from a whole web page down to just a single image. It is the destination for our digital letter.
And you can see here, that address has different parts. The HTTPS at the start, that's the protocol, the language rules we're going to use. The domain name, example.com, that's like the website's main street address. And that path at the end, that's like the specific apartment number. It tells the server exactly which file you want to see.
So, our address is all sorted out. Now we get to the journey of the request itself, which kicks off with your computer figuring out where in the world to send it. And this is the very first stop on the line, the DNS lookup. DNS means Domain Name System, and you can just think of it as a giant shared address book for the whole internet. See, we humans are good with names like example.com, but computers, they prefer numbers. They need a specific numerical address called an IP address.
So this is basically what your computer does. It shouts out into the network, "Hey, can somebody give me the IP address for www.example.com?" The DNS system instantly looks it up in its giant address book and sends the correct number right back. Okay, we've found the correct address. Now it's time for the main event, the actual conversation between your computer and the website's computer. This entire system is built on a really simple but powerful idea called the client-server model. Your device, your laptop, your phone, is the client. It's the one making a request. The computer out there that holds all the website's files, that's the server, and it's just waiting to serve up that information.
And this lays it out perfectly. Your browser, Chrome, Firefox, whatever you use, is the client. Its job is to make the request. Over on the other side, you have the server, which is the computer hosting the website. Its job is to send back the response. It's always a two-way conversation.
So, remember that special language we talked about? This is it. It's called HTTP, or Hypertext Transfer Protocol. It's just the set of grammar rules that make sure the client and the server can understand each other's requests and responses perfectly.
Now, not all requests are the same. HTTP actually has different verbs for different actions. Most of the time, when you're just loading a page, your browser sends a GET request. But say you're logging into a website or submitting a form. Well, then you're sending information to the server, so that's a POST request. Each verb has a very specific job.
The server has received our GET request. It knows what we want. So now let's look at its reply, the package that it's sending back.
The response that comes back has 2 main parts. First, there's the payload. That's all the actual files that make up the website. But it also includes a little note right at the top called a status code, which tells your browser how the request went.
I'm sure you've seen some of these before. A 200 code is the good one. It means success. Everything worked and the page is on its way. The infamous 404 means the server is working just fine, but it couldn't find the specific page you asked for. And if you see a 500, that means something broke on the server's end, not yours. The package has arrived.
Our browser has the files, we've got the 200 success code. Now it is time for the final and maybe the coolest step, unboxing the website. This is where your browser becomes both an artist and an engineer. It reads the HTML file to build the skeleton, the basic structure of the page. Then it applies the CSS file to add all the colors, fonts, and layouts, like painting the house. And finally, it runs the JavaScript, which makes everything interactive, the buttons, the videos, the fun stuff. It assembles all these pieces into the single, seamless website you see on your screen.
And that's it. That's the entire trip, from your keyboard across the globe to a server and right back to your screen. And the most amazing part? This whole complex round trip, it all happens in less time than it takes you to blink.
So, we'll leave you with this thought. We just followed one tiny request for one single website. Now try to imagine multiplying that by the billions of people clicking, searching, and streaming every single second of every single day. It's a constant global conversation on an unimaginable scale. And now you know exactly how it works.